In this video, I will talk about inverse secant function. This is another difficult function as we already discussed inverse tangent function. So first of all, we want to see how the secant function look like. We have y is equal to secant x. And this secant x, we want, if in order to find the inverse function, we restrict the domain from 0 to pi by 2, and we cannot include pi by 2, then union pi and 3 pi by 2. We restricted the domain. This is not the actual domain of the function. Let me just plot it for you over here. Suppose we have x and y axis, and we have 0, pi by 2, and pi. And on the negative x-axis, we have 0, minus pi by 2, and minus pi. It cannot crosses minus pi by 2. The reason is y can be written as 1 over cos of x. When we put cos of x equal to 0, then this becomes discontinuous over here and it becomes infinity. So this pi by 2 or minus pi by 2, these are the walls on which secant x cannot cross. So the actual function is, for example, when x is 0, you can see that when x is 0, 1 over cos 0 is 1. So it should start from 1 over here. When it starts from 1, it can go towards right like this, like a concave up, and remember that these are the walls. And similarly, the other part will go like this, and these are the vertical walls. This is just a rough graph, and you can see that this does not passes the horizontal line test since it passes through 2 points. So we have to remove one branch over here. So I remove this branch from the domain, and we consider only 0 to pi by 2. If I observe this function from pi by 2 to pi as well, and 3 pi by 2 on the right hand side over here, this is 3 pi by 2. The function is negative. At pi, we have minus 1 value. So this is actually 1, and this will be minus 1. The function starts from here. When it starts from here, it can move towards negative and concave down, and it should not touch the 3 pi by 2. The reason is this is its wall, it's a vertical asymptote. And on the other side, from pi by 2 to pi, the function look like this, but it does not passes horizontal line test. It passes through 2 points. So we remove the negative, the other branch of that function too. So we have this function, this branch over here, and we have this branch over here, this branch over here. These two branches we will take for the secant inverse of secant x. Why we want to take two branches? The reason is it completes one complete oscillation in these two branches. That's why we took these two domains. One domain is 0 to pi by 2 and another is pi to 3 pi by 2. It repeats everything afterwards. That's why we have this domain over here. So now we come to so we already decided this is our candidate for the secant inverse x in this domain. These are the domains. The actual domains are different, but we restricted our domain 0 to pi by 2 and union pi to 3 pi by 2. The first step to find the inverse is replace y with x and x with y. That's first thing we do. And domain becomes range and range becomes domain. So y is 0 to pi by 2, 0 to pi by 2, or another part is pi to y can become minus from pi to 3 pi by 2. This was the domain for secant x. When we interchange the values, then this becomes range and domain becomes range and range becomes domain. I'm sorry. So for inverse function, and we just write it like this, y is equal to secant inverse x, where y is already decided, but the question is what is x? So y is pi to 3 pi by 2. What is x? You can see that it starts its value in the range from 1 and also from -1, something like that. So it means that its range will be the domain. So this value in the range and this value will be the domain. So the domain will be x mod greater than or equal to 1. That is interesting. I hope you understand this concept. Range becomes domain and domain becomes range. The range of y is equal to secant x was, it starts from 1, so this becomes domain and this becomes domain as well. From here, this becomes domain as well. Okay, that's why we have x mod is greater than or equal to 1. So in this way, we continue with other trigonometric function as well. So you got the idea in these 3 videos. So let me just write inverse cosine function for you as well. Inverse cosine function. I will not plot it, but you got the idea. And let me just plot it for you as well. Maybe I missed that. First, let me just plot it for you. Secant inverse x. So this is x, this is y. Since the domain is 1 to -1, so we write 1. This is -1. When x is -1, we know that the value will be the pi. So at x is equal to -1, the graph will be look like this, -1 pi, and it should not cross 3 pi by 2. It should not cross this value, which is 3 pi by 2. On the other hand, when x is 1, the value is 0. The value is 0. So we have a graph like this. and it should not cross pi by 2. It should not cross pi by 2. This is the rough plotting. So it looked like this, something like this, and then we have something like this. This is the horizontal line, this is the another horizontal line. So that's how the graph look like. For inverse cosine function, we write y is equal to cos inverse x, and x will be -1 to 1. This is the domain. Actually, this was the range. For range becomes domain and domain becomes range. And y is 0 to pi, since so we restrict the domain from 0 to pi. If you, for example, just plot that function, quickly we are talking about y is equal to cos x. Cos 0, it is 1, and cos pi by 2, it is 0, then it is -1, and so on. So it satisfies the horizontal line test when we restrict the domain from 0 to pi. That's why we have 0 to pi as a range, since range becomes domain and domain becomes range. You should remember this rhyme. And similarly, for y is equal to cotangent x, cot x, in that case, x is minus infinity to infinity, and y is 0 to pi. Cot x can be written, it is the inverse of tangent. So cot x can be written as cos x over sine x. So there are discontinuities when we have sine of x is equal to 0 and x is 0, pi, plus minus 2 pi, and so on. So we restrict the domain from 0 to pi. You can see it yourself. I hope you can get it, the idea. The next function, y is equal to cosecant x. For cosecant x, we have x mod greater than or equal to 1. It is similar to secant x. And y should be minus pi to minus pi by 2. Or y should be 0 to pi by 2. You can plot it yourself first, cosecant x. First you plot cosecant x over some domain, and then you change the domain into range and range into domain. So that's how we understand the inverse trigonometric functions. Thank you for watching.